Hello, this is Marlena Snellick with A Plus College Ready, and today we are going to start the first part of our unit on Unit 7, which is solutions. So solutions can be a variety of things. It can be solids into solids, solids into liquids, liquids mixed together, and so depending on what's mixed together will depend on the name that we get it. So we're going to give it. So today we're going to start with solids into liquids. So there are two main different types of mixtures that you probably know about. They're either homogeneous mixtures or heterogeneous mixtures. So homo means same, so these are when we dissolve a solid into a liquid and it looks like it is completely the same throughout. So this would be like a mixture of Kool-Aid. So when you put the powder into the water, it mixes it evenly throughout and it's very difficult to separate. So that would be a pure solution or a homogeneous mixture. Hetero means different, so a heterogeneous mixture would be something that's very different throughout and is very easy to separate, and we call these suspensions. So this would be like Italian dressing. So Italian dressing, you can see it settles out very quickly if you set it out on the counter, so that would be an example of a heterogeneous mixture. A colloid appears to be like it's a homogeneous mixture, but if you leave it out over time, it will settle out. And the most common example of a colloid would be milk. So milk looks like it's the same, it looks homogeneous, but if you leave it sitting out on the counter, you can quickly see the different layers that will well, not quickly, you could slowly see the different layers that will settle out. You can tell the difference between a homogeneous mixture and a colloid by using the Tyndall effect. So if you shine a light, like you see in this picture, through, instead of the light passing straight through, it will scatter, and that lets you know that it's a colloid and not a homogeneous mixture. You can also dissolve liquids into liquids, and sometimes they will dissolve, and so this is called a miscible liquid, and sometimes they will not dissolve, so that would be called immiscible. And the rule that we use for this is like dissolves like. So if something is polar, it will dissolve in something that is polar because of that attraction, or if something is nonpolar, it will dissolve in something that is nonpolar. However, if they are different polarities, then they will not dissolve, like oil and water. Water is polar, oil is nonpolar, so if you try to mix them together, it doesn't work. They just separate, so we would say that they are immiscible. Solids into solids is a little bit more difficult because that's not something that you think of as far as mixing together. So if we're going to make a solid into a solid, then you actually have to melt them. So an example of this would be an alloy, and most jewelry is actually an example of an alloy. So for instance, like white gold isn't just gold, it's just a mixture of silver and gold and copper, and it's just got more silver than anything else, which gives it the lighter appearance. So most jewelry is an example of an alloy where we've heated things together and mixed them up. Gas into gas is something like the air that you breathe. So the air that we breathe is a mixture of all different kinds of gases, and so that's an example of a mixture of gases. A gas can also be dissolved into a liquid, and the most common example of this would be like a carbonated beverage, so like a Coke or a Sprite or something like that. And the amount of gas that you can get to dissolve into the beverage depends on two things. It depends on the pressure and it depends on the temperature. So when you crack open a Coke, you'll hear like that fizz or that pop. And that's because the pressure has been kept on that beverage to keep the gas dissolved in it. But as soon as you open it, some of that pressure is released, and so some of that gas escapes. So this is why if you leave it sitting out and you don't cover it back up or put the cap back on, then it loses its carbonation very quickly because all of the gas escapes. Same thing with temperature. If you want to keep a beverage with its carbonation longer, then you want to keep it colder. You want to keep it in the fridge. Because cold water is going to keep more of the gas dissolved longer than the warm, because the gas is moving slower in something that's cold versus something that's warm, so it will stay dissolved longer. When we're talking about solutions, there are two different main parts of a solution. So there's the solute and the solvent. So the solute is what you're going to dissolve, and the solvent is what you're dissolving the solute in. And together these two things are what make up a solution. So going back to the Kool-Aid example in the beginning, the Kool-Aid powder would be the solute, the water would be the solvent. It would be what's dissolving the Kool-Aid powder. If a substance can be dissolved, then we say that that substance is soluble. And so we can measure how much is dissolved by measuring the solubility. And we use three different terms to really describe the amount of solute, or the solubility, or the amount that has been dissolved. So that's unsaturated, saturated, and supersaturated, and they sound about, the definition is about the way the terms sound. So unsaturated holds less than the maximum amount of solute at a certain temperature. So when we're talking about the solubility and the amount that can be dissolved, it's got to be talking about at a specific temperature, because if you change the temperature, then you change the solubility. So unsaturated would be it holds less at that temperature that can be dissolved. So you have the ability to dissolve more. A saturated solution holds the maximum amount of solute possible at that temperature. So if you added more in there, it would just sink to the bottom. It wouldn't dissolve anymore, so it's saturated. It's got the maximum amount. If you want to make a solution that's super saturated, you're going to have to heat it up, because remember we just said saturated holds the maximum at that temperature. So if I put any more, it wouldn't dissolve. So if I want to dissolve more than a saturated solution can hold, then I've got to heat it up and dissolve more in there and then cool it back down. So if you look at this picture, that's actually how rock candy is made. Is you make a super saturated solution of sugar and water, and then you cool it down, disturb it, and then all of the sugar crystals will recrystallize on the string and you have rock candy. So solubility is the amount of solute that's needed to make a saturated solution at a certain temperature. And so if you look at this chart here that you're going to see again, so make sure that you understand it. So let's look at KNO3, so the potassium nitrate, so this pink line here. If you look at 0 degrees Celsius, 100 grams of water can only dissolve about 14 grams of the potassium nitrate. But as the temperature goes up, so does the solubility. So at 40 degrees Celsius, we can dissolve 60 grams in 100 grams of water as opposed to just 14. So warmer temperatures are going to typically hold more solute, and colder temperatures are going to hold less solute. So when you're looking at the solubility, it's going to have a great dependence upon the temperature. There are some things that you can do that can increase how fast something dissolves. So if I want something to dissolve faster, there are some things that I could do. And for the first thing is I can increase the surface area. So think about this like if I had cubes of sugar versus granules of sugar. So if I want my sugar to dissolve quickly, I would crush it up and then pour it in. And this is just because more of the solute molecules are going to interact with the solvent molecules. So the more they collide and the more they interact with one another, the faster that they will dissolve. You can also stir or shake something. So if you've ever made sweet tea, you don't just pour the sugar in there and then just let it sit and wait for it to dissolve. No, you stir it up and you keep stirring it until all of the sugar is dissolved. And that's again because we're trying to increase the interaction between the solute and the solvent molecules. So the more that they collide, then the faster that they are going to dissolve. And the third thing that you can do is you can increase the temperature. Okay, so when I increase the temperature, we've talked about IMFs before, or intermolecular forces. It breaks those intermolecular forces between the solvent molecules, so it frees up more solvent molecules that can collide with the solute molecules, because again, like we said before, the more contact that they have, then the faster that they are going to dissolve. And this would be a wrap up on the unit. So I hope you learned something, and I'll see you for part 2.